All right, now to move on to our last example, example 5. We want to write a possible explicit rule for the nth term of the sequence. So again, our process for this is going to look very similar to what we did in the last one. We're first going to see if we can identify a common difference between each of these terms going from one to the next. So to get from 1.5 to 4, we'd have to add 2.5. To get from 4 to 6.5, we'd have to add 2.5. 6.5 to 9, we'd have to add 2.5. And 9 to 11.5, we'd have to add 2.5. So we have this constant rate of change to get from one number in our list to the next, meaning that this is going to represent a linear model. And the fact that we're adding this 2.5 every time, we have this constant rate of change of adding 2.5, means that that's going to be our slope. So I'm going to take my term number and multiply it by 2.5 because 2.5 is my rate of change, so I'm going to multiply that by my term number. Now, from here we need to figure out, is this explicit rule that I've written just applying the slope going to work, or do I need to add or subtract something to this to actually give me the values in the sequence I have listed here? So let's test it out. A sub 1. Well, if I plug 1 in, I'd get 2.5 times 1. But that's just 2.5. And we know a sub 1, according to my list of numbers here, my very first term is 1.5. So now we have to think about, well, what do we need to do to get from 2.5 to 1.5? With a little bit of trial and error, you'd figure out that we need to subtract 1. So that means over here, I need to have a 2.5 minus 1. So I've gotten this 2.5n minus 1 equation or rule to work for the first term, but now let's make sure it works for another. So I see that my first term is 1.5 and I know that it works. Let's pick one further down the line. How about our fourth term when n is equal to 4? We should get 9. So let's test it out. All right, so a sub 4 equals 2.5 times 4 minus 1. Well, 2.5 times 4 would be 10. And minus 1. And that would be 9. So it works. And so we know 2.5n minus 1 is our final explicit rule for the sequence written down. So when you find that it's linear, first thing you need to do is take that constant rate of change, that first difference, or how you're jumping from one number to the next, and that's your slope. That's your number you're going to multiply by n. From there, it's a little bit of trial and error to figure out what you're adding or subtracting from that to get your actual numbers within the sequence. That's the end of 9.1, introducing sequences. And if you have any questions, please let me know. Other than that, you can move on to the 9.1 homework assignment.